Hello students, welcome to Go Vidya and welcome back to the 1000 important series questions. Today we will completely discuss about the synchronous motion questions. So let's move to the first question. A three-phase 11 kV 5 MVA alternator has synchronous reactance of 10 ohms per phase. Its excitation is such that the generated EMF is 14 kV. If the alternator is connected to infinite busbar, the maximum output of the given excitation. In the question, we have to calculate the maximum output. And we know the formula of the maximum output, P is equal to EF into Vt by Xs sin delta. In the question, EF they have given as a 14 kV. Induced generated EMF or induced EMF is same, which is 14 kV. So EF is equal to 14 kV. Coming to the Vt, terminal voltage. Here the three-phase 11 kV, that has been as a terminal voltage. Vt is equal to 11 kV. And we have to calculate maximum output. So the delta angle will be 90 degrees. Clear? So in this calculation, everything we have to calculate with respect to phase values. So everything should be phase values. So let's calculate that. P is equal to, then what is the Xs? 10 ohm per phase. So we have to make calculation with respect to phase values. So 14 into Vt is 11 kV. I'll write together as 10 power 6, 14 into K cube, and this is cube. In together I have written 10 power 6 by Xs is 10 ohm per phase, and sin delta angle is 90. So sin 90 is 1. So if we calculate that, we know 14 into 11 is 154 and 10 power 6. So 1 will cancel and 10 power 5, and this is sin 90 is 1. So I can write 154 into 10 power 5. So I can write 15400 kilowatts. So this is the maximum power output we can calculate. So the option A, 15,400 kilowatts. So remember one thing, if you know the formula also, if you are not following, whether I have to do in the phase value or the line value, that is very important. You have to know that. Everything we should perform with respect to phase values. We have to calculate with respect to phase values. Then you can get the correct answer. Clear? So let's move to the next question. A synchronous motor is floating on a infinite mains at no load. If excitation is now increased. So the motor is floating on infinite mains at no load, which is it is not having any mechanical load. But if the excitation is increased, here what does the excitation means? Field current. If the field current increases, what happens? Actually, at no load. At no load means no mechanical load. No mechanical load is present. But in the question, if excitation increases, what happens? Excitation is nothing but field current. If the field current, if IF increases, what happens? Yes. If field current increases, the motor will shift to work under leading power factor. The motor shifts to leading power factor. And one more, if excitation increases, it will work as over-excitation. It will work under over-excitation. If that works under over-excitation, the motor shifts to the leading power factor. If the excitation decreases, it will work under under-excited condition. In the under-excited condition, it will act under lagging power factor. Okay, if IF increases, if IF decreases under excitation, under excitation. And under excitation, this is lagging power factor. Clear? So in the question, excitation is increased. So if excitation increases, it shifts to the leading power factor. In the question, unity power factor will works under the normal excitation. Normal excitation. And it will draw zero power factor lag current? No. Lag is for if excitation decreases, IF decreases. It will draw zero power factor leading current? Yes. If excitation increases, the motor will shift to the leading power factor, which is it will work under the condition of over excitation. So in the question, if the excitation is now increased, then it will draw zero power factor leading current. Clear? So make a remember of all these points. Clear? So let's move the next question. A 230 volts 3-phase synchronous motor driving a pump is provided with a line ammeter and a field rheostat. When the rheostat is adjusted such that AC line current is minimum, the ammeter reads 8.8 amperes. What is the power being delivered to the pump, neglecting the losses? We have to neglect the losses and we have to find what is the power delivered to the pump. In the question, a 3-phase 230 volts and the ammeter reads 8.8 amperes. So power delivered, P is equal to root 3 VL IL cos phi. So root 3 into VL is 230 volts and current is 8.8 amperes into 1. So if root 3 is 1.732 into 230 into 8, we'll get 2024. So the value 1.732 into 2024, you will get around 3.5 kilowatts. So the power delivered to the pump is 3.5 kilowatts. Clear? See, the question seems very clumsy, but the data, by taking the data, you can easily calculate the questions. Clear? So the option B will be the answer, 3.5 kilowatts. So let's move the next question. In order to minimize both fifth and seventh harmonics, this is fifth harmonic, fifth and seventh harmonics, the coil span in 3-phase AC machine must be. So to eliminate the fifth harmonic, to eliminate any nth harmonic, to eliminate any nth harmonic, we have a formula n minus 1 by n. N minus 1 by n. To eliminate the fifth harmonic, we have into 180 actually, into 180. So to eliminate the fifth harmonic, 5 minus 1 by 5 into 180. You will get 4 by 5 into 180. So 5, 3 and 6, 30, 6 times. So you will get around 144 degrees. So to eliminate any nth harmonic, the formula we use is 180 into n minus 1 by n. So to eliminate the fifth harmonic, 144 degrees. If to want to eliminate the seventh harmonic, in the question they have given the seventh harmonic also. So we can write 180 into seventh harmonic, 7 minus 1 is 6 by 7. So we will get around 154.03 you will get. In around I can take approximately as 154 degrees. But they said to find out the coil span. So in order to find the coil span, we have to combine both the fifth and the seventh harmonic, both the harmonics. So 144 plus 154 by 2. So you will get around 144 and 154, 8, 9, 298 by 2, which is around 300. So I can take 150. But coil span they have asked, so I will take 150 by 180 into pole pitch. Pole pitch. So 3 5 3 6. So overall get 5 by 6 into pole pitch. So 5 by 6 into pole pitch value. So the coil span of both 5th and 7th harmonic is 5 by 6 into the pole pitch value. If you see the option A 144, no. If you eliminate the particular 5th harmonic, you are going to get 144 degrees. 6 by 7, no. 120 is no. So option C 5 by 6 into pole pitch value. Clear? The short circuit current at 1000 rpm is 20 amperes for the field current of 1 ampere. The short circuit current at 900 rpm for the field current of 1.5 amperes is. So in the question we have to calculate the short circuit current, and they have given the two field currents and the two speeds. And to solve this question we have to know one condition, that it is independent of the speed. If the speed decreases further, in the question they have given 900, if they have given at 200 rpm also, that doesn't matter in this question to solve this question, because it is independent of the speed. It depends upon the impedance values and the some EMF's value. Clear? So we'll solve the question. And one more thing, short circuit is directly proportional to the field current. Short circuit is directly proportional to the field current. So ISC1 by ISC2 is equal to IF1 by IF2. So I have to calculate this ISC2 value, short circuit, second short circuit current. We will calculate that. The field current 1 value is 1 ampere and 1.5 amperes. We will do directly. ISC2 is equal to, and the short circuit current first one is 20 amperes. So 20 into 1.5, directly I am writing the value. 20 into 1.5, I will get 30 amperes. 30 amperes. Clear? Short circuit current is directly proportional to the field current and it is independent of the speed. Clear? An alternator is supplying a rated load current of 20 amperes for a pure capacitive load at 1000 rpm. If the alternator is running at 900 rpm for the same load and the same excitation, the load current will be. Speed has been decreased, first point, and we have to calculate the same short circuit current for the same load and the same excitation, the load current will be. It is independent, as before for the last question I have said, it is independent of the speed. Yes, to avoid that confusion I have bring this question immediately for you. So same load, same excitation. Definitely the short circuit current will be also same, because ISC is directly proportional to IF. Excitation is same, field current is same. Obviously the short circuit current will also be same, because it is independent of the speed. So this looks very simple, these points, but these points are very important while solving the problems within seconds. Independent of the speed. So if the field current is same, obviously the short circuit current will also be same. So if this is 20 amperes in the question, definitely the short circuit current also will be 20 amperes. If in the question, if the excitation has changed, definitely the short circuit current also will be changed. Clear? So the answer will be less than, greater than, data insufficient. No, it will be 20 amperes only. Clear? So let's move to the next question. A 3-phase 4-pole alternator has 120 slots. The coils are short pitched by one slot. The value of pitch factor. So we have to calculate the pitch factor. Pitch factor. But one more thing, if you observe the question, they have given that the coils are short pitched by one slot. Very important. The coils are short pitched by one slot. So pitch factor is denoted by the letter Kp. Pitch factor is denoted by the letter Kp is equal to cos alpha by 2. But to calculate the alpha, I have to know the coil span, everything I have to know. But in the question, the short pitched by one slot. So I can write alpha is equal to gamma. Yes, if it is short pitched by, as it is short pitched by one slot. So I can write 180 degrees by slots per pole. So 180 by, this is gamma. Slots are 120 slots by pole. How many poles? 4. 180 by 30 is 6 degrees. So gamma is equal to 6 degrees. So can I take alpha is equal to 6 degrees? Yes, because it is short pitched by one slot, I have taken alpha is equal to, or gamma is equal to alpha. Gamma is equal to alpha. You can write anything. Gamma is equal to alpha. Clear? So we'll substitute that. Kp is equal to cos of alpha is 6 degrees by 2, cos 3, you will get around 0.998. So the pitch factor is 0.998. Clear? Because in the question they have mentioned the coils are short pitched by one slot. Clear? So let's move to the next question. Read the following statements about cylindrical rotor alternator. Cylindrical rotor alternator. This is generator. The first option, if you see, EMF generated by armature reaction MMFs lags armature current by 90 degrees. Clear? In the first question they are saying that armature current EMF. So by Faraday's law we know that flux and generated EMF are lagging by 90 degrees. Clear? So this will be the flux, armature flux, and this will be the armature EMF. According to Faraday's law, we know in general it will lag by 90 degrees. It will lag by 90 degrees. So option 1 is correct. Armature reaction MMF is nothing but the flux. So can I say armature reaction MMF is the flux? Lags the armature current by 90 degrees. So, and moreover, one more thing I can say that we know the formula phi is equal to N into I by R. So phi is directly proportional to armature current. Yes or not? Now coming to the flux and the armature current will be in phase with each other. Because in the question armature current also they have given. Sorry, this is not, this is EMF. This is armature EMF. Clear? Sorry for that. Armature EMF. And this is armature current is IA. We know phi is directly proportional to armature current. Now it lags or not, definitely it is lagging by 90 degrees. So option 1 is correct. So directly if they have asked the flux, we can say, but they have asked in the question about the armature current. And we know the relation phi is directly proportional to the armature current. And the option 1 is correct. Coming to the second option, armature current due to intermediate lagging power factor is partly cross magnetization and partly magnetizing. It is talking about the generator. It is talking about the second one. Talking about the generator. First thing you have to know. In generator, they are telling about the lagging power factor. Lagging power factor. In generator, the lagging power factor, what does it do? Partly demagnetizing and partly cross magnetizing. So coming to generator, if it's a lagging power factor, partly demagnetizing, partly cross magnetizing. Clear? In the question is generator lagging power factor is partly cross magnetizing but partly magnetizing. This is wrong. That should be partly demagnetizing. Clear? If it's a motor, that is okay. If that is a motor, that is okay. If it is for a leading power factor, partly magnetizing and partly cross magnetizing. Clear? So option 2 is wrong because of partly it is demagnetizing, not magnetizing. Clear? Next, air gap voltage leads the terminal voltage. If you have the idea of the analysis of the cylindrical rotor alternator, and you will see a graph like this. This is Vt and this is voltage. And if you observe here, air gap voltage will be an intermediate factor between the terminal voltage and the EMF induced here, and this will act like a intermediate thing. Air gap voltage will act like an intermediate factor. In the question, air gap voltage leads the terminal voltage. Air gap voltage leads the terminal voltage. Yes, it is correct. It leads the terminal voltage actually by some angle delta. Clear? So option 3 is correct. Next, air gap voltage lags the field flux by 90 degrees. Is it correct? No. If in the question they have mentioned air gap voltage or air gap flux lags the field flux by 90, that is correct. But in the question, air gap voltage lags the field flux, that is not correct. So option 4 is wrong. If in the question air gap voltage leads the field voltage or field voltage by 90 degrees, that will be correct. But in the question, air gap voltage lags the field flux by 90 degrees. No, that is wrong. So clear? So from the above options, which of the following are correct? 1 and 3 are correct. So the option B will be the answer. Clear? So thank you everyone.